graph on this?
So don't find inverse?
Maybe domain. No range, no asymptote, no inverse. Yeah, kind of. This one right here, what is that? That's 3 to the x. We could rewrite that as negative 3 to the x plus 1, right? So we graph 3 to the x first, which we know is exponential growth. A negative reflects it over the x-axis, so it's actually here, and then up 1, so it moves the whole graph up 1. So our final answer would be, somewhere around here. Yeah, you get the idea. Okay, what about this one?
You need to know what
I'm first going to graph 3 to the x, because that's right. That's your inverse of that. So 3 to the x again looks like this.
And then it's going to go to the right.
Well, hold on. No, we graph the inverse first, then move it around.
Oh, okay.
So that's 3 to the x, right? The log function is the reflection of that over the identity, right? This is where we made the table for this, and then we switched all the points.
Oh, right.
And we come here and we graph the log. And if we graph the log, this would be it in red. So this is the log base 3 function, right? Now, what does do the inside first. What does this do?
Goes to the right 5.
To the right 5, opposite of what you think, right? Because it's inside, so you go 1, 2, 3, 4, 5. You draw it again, like this. And then doubling it, what's 2 in front do?
It just makes it bigger.
It stretches it vertically. Now, I probably won't ask you to stretch vertically, because it's hard to draw stretch vertically. But I will ask you to move it around. Questions on that? It's a quick sketch.
So whenever there's a log,
Do what?
like for that question, you need 2 lines?
2 lines. What do you mean 2 lines?
Oh, he's asking, do you want us to also graph the inverse? Because you're asking for the, I guess the log.
You don't have to graph this one. What you can do is make a table for the 3 to the x, flip these, and just draw the red one, and then move it around.
But typically, whenever you have log, is it just the inverse across the x equals y?
It's the reflection across x equals y, yes.
And you said you move it over to the right 5. Will we have an asymptote at 5? Or?
Yes, because it used to be the y-axis.
Yep.
It moves over 5. So it's now going to be at x is 5.
How do you
Vertical.
want us to really picture that for your sketches? Just won't put a 5 there? Or?
Put your 5 and then draw a dotted vertical like that, yeah.
But do you want the steps or just with the final one?
The final one's okay.
Yeah, I can't put video in my head.
Final one's okay. Just make sure it's not just you drawing what your calculator says to draw. You know what I'm saying?
Right.
Yeah.
Like you wanted to make sure that we know what we're doing.
Yes. All right, fill in the blank. The domain of a basic exponential function is
All real numbers?
all real numbers. The range of an exponential, basic exponential function is
0 to infinity?
0 to infinity. Domain of a basic log function is
0 to infinity?
0 to infinity, not including 0, right?
Right.
And then the range of a basic log function is all real numbers. Logarithms are fun.
Inverse functions?
Awesome. There's a lot of different answers you can have for this. Logarithms, I think what she wanted in this review was logarithms are exponents. I mean, they are, right? Remember we had logs, and I said all log is an exponent written in a different form?
Right.
So logs are exponents.
I know you wouldn't ask for a word problem like that.
I wouldn't ask that. But this is just, do you understand what's going on?
Right.
Exponentials and logarithms are
Inverses?
inverses of each other. Exponential functions can be used to model
Growth or decay?
growth or decay, good. Logs can be used to model, well, we haven't talked about that too much, so we don't have to worry about that. Exponential functions have blank asymptotes, logarithms have blank.
Horizontal and vertical?
So horizontal and vertical. So horizontal for exponential, vertical for logs. All right, given the two one-to-one functions below, find their domains, ranges, and inverses. I would ask you to find their inverses. I wouldn't ask domain and range. So these problems, This is where you say, okay, replace f of x with y. Switch x and y. Solve for y, right? This b is probably more like in line of what you would see.
I was about to say, the second one would be something you would do.
Yeah, this is like a parabola where you have to cut off half of it, and I'm not going to go there. You okay with that? Keep going?
Well, that's the point of, never mind.
All right, we talked about this. In calculus, I said that you run into these problems where we have a function that looks really complicated, so we break it down into the composition of some easier functions. And we did a few, and everyone kind of had different ways of doing it. Like there's more than one answer to this. So can you rewrite this capital H so that it's the composition of two functions, where it's f of g? So give me some answers here. We can have
F could be 5 over x,
5 over x,
and then the bottom one could be that whole thing.
the whole thing, like this. Do you all agree with that? If I take this expression and I plug it into that x, then I get this. That's one answer. Any other?
5 over x.
Hold on, let someone else answer.
5?
5 over,
No.
Let's do
X cubed.
hey,
I mean,
x cubed, g of x is x squared plus 1, right? That would work also? So you might have different answers. But do you understand what's being asked? The thing that always gets me on tests is when I have a review like this and I give a problem very similar to it and then the student leaves it completely blank. It either means like you're a really bad test taker and your brain completely froze, or you didn't really take the time to go back and look at what I'm going to ask. Because if you don't have no idea how to do it, it's either you completely forgot it or you didn't take the time to learn. Yeah, just like, okay, I don't have any idea how to do that.
although I could see you
Yes.
giving something more complicated.
Do you want us to explain like just one way to do it?
Nope. Any way, because you might have different answers and I can always look at them and tell.
Okay.
Although I could see
You
you
gotta
doing
understand
something
that the
like,
brain has an exponential decay, and perhaps it's very.
I could see you doing like something a little more complex.
I think we did in class one that had 3 compositions, yeah.
And there was one more.
All right, find the domain. Okay, this is a good problem. These are logarithmic functions or equations, and you need to find domains. So do you remember, I think it might have been last class, where I said, hey, I need to go back and talk about domains of logs. I don't think that I got that clarified enough. This is exactly what that has to do with. So what is the domain of that right here? So what can you tell me about logarithms?
What's gotta be positive?
What's inside of it? The argument, right? This thing right here must be bigger than 0. It's got to be positive, right? Can't plug in negative numbers, can't plug 0 in. What type of thing is that? Quadratic inequality. How do we solve quadratic inequalities? Start by setting it equal to 0. Good. And then once you set it equal to 0,
You can just factor it out.
you solve, yeah, this might factor, it may not. Does that one factor?
Well, there's that. I don't think it does. I mean, you can do quadratic. And that will tell you.
Quadratic formula is our fallback, right? What we have just in case. Is it not working?
No, it works.
It works? What is it?
Well, can I say something and you write it down? Okay, yeah.
Okay, you want me to?
I would need to write it down because I usually do 2 times 15, that's 30, so it'd be 3 and 10, and then you divide both sides by 2.
Good. So I think that's it, right?
Yeah, that's it.
Yeah.
I have to do it.
That's what we're.
Yeah, I have to write it too. I don't see it right away until I write it down.
Just like pull it out.
So you should get 2 answers. X is 3 halves, and the other one is x is negative 5. Now what?
You
Plug it into the
gotta test the point.
You have to do test points, or there's a couple of ways. You can just, you write down these numbers in order, right, on a number line.
So 1.5.
1.5 is over here, negative 5 is over there. I don't want those points, right?
No. So you're gonna do probably like -6, 0. And then
I can
something in the
test,
middle. You can't do
right?
0, you gotta do 1.
Oh, you can do 0.
Oh,
It doesn't,
Yeah.
it's not equal to.
You're testing them. You're testing them, right? That's all you're doing. If you plug 0 in here, You're just going to see what happens. Right?
You get negative 15.
Because I thought you couldn't have a log of 0.
Well, if you plug 0 in here, you're not even going to get 0. You're going to get negative 15, which is even worse.
Right.
But don't eliminate the possibility of 0. Remember, it's not what you're plugging in for x. It's actually what comes out of this expression that can't be plugged into log. Like, this whole thing cannot be 0. This whole thing cannot be negative. Not the x that's going in.
Okay.
Now, I like the idea of testing points. That's great. But there was another way I explained you could do it, and that's just to think about what this would look like if I graphed it. Just that part right there. It's a parabola, right?
Yeah.
Opens which way? Up. So, and these 2 points are x-intercepts, aren't they?
Yeah.
So that, if I graphed it, would be this parabola, right?
Right.
And I want to know when it is what? Bigger than 0, and that means over here it's above the x-axis. It's bigger than 0 over here. It's bigger than 0 over here. So I get the same answer as I would have had I tested points, but it's a little quicker. For me, I like this way.
I like that too.
It's just that if it's not a quadratic, you can't do this.
Right. Then you actually have to have one.
So what would the domain of this be?
So negative infinity to negative 5.
Not including, right?
And then parentheses, three halves.
Good. That's it. You all see that? All right, what about the next one? Next one's kind of tricky.
Yeah. So now, well, you can break it down into 2 separate logs, but you don't want to do
Tell me, generally speaking here,
Well,
about the inside of that. This must be what?
well, the bottom can't be 0.
Bottom can't be 0, I agree.
X cannot be 5.
Right.
Off the bat.
Yes, x cannot be 5, and the whole thing must be bigger than 0, right? When I plug a number in for x, at the end of the day, once I figure out what that is, that has to be bigger than 0. Because what I plug into a log must be bigger than 0. I also can tell right away x can't be 5. But what is this if I asked you to think about that visually?
It's a rational.
Rational function.
You can graph that.
We could graph it. And what I told you is for these domain problems, don't go through the whole set process of graphing it. Just find 2 pieces, the x-intercepts and the vertical asymptotes.
Which that would be just x.
Which would be what? What's the x-intercept of that graph?
Negative 2.
-2.
I'm sorry, 2.
That's an x-intercept. And the vertical asymptote is at 5. And what you do now is you test some points here, here, and here, right?
Now you have to test it.
Now you can just test them. So let's plug in -3. What happens if you plug in -3 into this?
Isn't the vertical asymptote at -2?
So it's a
No.
negative-
That's the x-intercept, because that makes the top 0, but the bottom not.
So it's a negative divided by negative, so it's positive.
So when you go -3 in here, you get negative, negative, it's positive. Is that true? That works?
Yeah.
Yes, so this would work. By the way, I'm just going to kind of break up this right here. That's not a vertical asymptote. That's just kind of me partitioning. I've got 3 sections here, right? Let's plug in a number right here.
0?
0, yeah, sure. See, you can plug 0 in.
Yeah.
When I plug in 0, I get 2 over... Wait a minute. Hold on. Yeah. So you get a negative here. Yes, that doesn't work. And then if you plug in, say, 6, you should get positive. It's good? Okay. So it looks like you're going to have everything, what, over here all the way to -2. Now, what about -2? Can it be -2?
Yes. No, because it's
Why
equal
not?
to, because it's equal to 0 at that point.
Yes, if I plug in -2, I'm going to get 0 over this. 0 is not bigger than 0.
Right. So that would not be.
So that won't work. So my domain over here would be everything all the way up to -2, union
Negative 2. No, wait. So 5.
5 to infinity. Make sense? Not including 5? Pardon?
That applies to all x-intercepts though, right?
I'm sorry?
That applies to all x-intercepts.
For yes. For a logarithm.
You can't include 5.
If this is a logarithm, yes, then we can't have x-intercepts in there. We good? What time we got? Oh, we're doing good. I don't know how long this review is, so I don't know how far we have to go still.
How many questions do you have on the test?
I haven't written the test. Oh, wait, I started writing the test, but I haven't finished it.
So more or less, I mean, like 20 questions?
Usually it's about
I don't know.
5?
I don't know. Because I could have one with multiple parts and.
And then what's in it, or about,
There's
what
25
about
questions on it.
a third?
What about this one? This comes from last class, I believe.
How many questions are
Is this last class that we did that?
Right, expand.
Write that expanded form?
It was the last class or the one before that?
Yeah, I don't recall. Can you expand that or no?
Yeah,
You sure?
yeah.
Hold on. Hold on, we have a visitor.
30 seconds of your time.
This guy's gonna try and sell you something. Don't, no.
It's all about the Lakers. That's what I'm
Don't
talking
listen to this guy. He's.
Hey guys, real quick. I'm sorry. I know you guys, the math people, are like, I don't even have 30 seconds, so get going. So I'm gonna move pretty quick. My name's Tony Montalbano. Teach in the English department. He's in my creative writing class right
I
there.
can't spell.
That kid, yeah, take it right there. But I just wanted to announce we're accepting submissions for our literary magazine. I usually just go to the English department, but I decided, man, there's a lot of cool people that are older that are just not, and they're taking math and they're interested in art, and writing, and poetry, and fiction, or whatever.
They're not.
This particular class
No,
might
I'm
not
just
be,
kidding.
but this is we're taking this as submissions, and what it is it's a lit mag like every cool college in America. It's poetry, fiction, art, whatever you're into, digital media. It could be photography, it could be sculpture, whatever you're into. We would like you to submit it because if you get accepted, if you submit, you get accepted. It's a pretty big deal. We got a big party. I throw a party with the jazz band. The school jazz band shows up, and we project the art all over the walls, and we listen to poetry, and we snap our fingers like hipsters for like an hour. It's a lot of fun. So hopefully you guys will submit. This was last year's cover and first place prize. This was the year before that.
I'm still waiting on my copy.
I'll give you a copy, young man. Yeah. I know where you are, so I don't have to hunt you down. I'll put a couple of these out here if you guys have interest. Anytime in the world, just grab one, and the details of when to submit and all this stuff. The deadline's here in about 3 weeks or a month. So I'd appreciate it if you submit, because without you guys, we don't have a literary magazine. It's pretty competitive, though. I will admit that. So.
All the mine's were great.
And Jacob's going to get in it.
Are you only allowed to submit one thing?
You're allowed to submit lots of things. The details
Roses
up
are
to
red.
Up to 8.
I have the
Yeah,
details.
please submit that poem for me.
Okay,
That would be
I got to remember the rest.
Yeah, roses are red. The Spurs just lost.
Hey, easy. You better get out of here.
I'm Laker land. I can't talk any smack. It's terrible right now. Thanks, guys.
Thanks, no
See
problem,
you
Tony.
good.
He's funny, that guy.
Yeah.
So you're gonna do,
You subtract that, when you separate those two, it turns into a subtraction between the two logs.
Okay, you have to do that first, right?
Yeah.
This is pretty ugly looking.
Yeah, beyond that, I'm still.
Well, then there's a
then you have the
multiplication on the bottom.
multiplication.
You can add those.
And there's another one for multiplication.
I'm sure there's something for that.
Is that okay for first step?
Yeah.
So then
Break down
add
the
those
second.
two.
Yeah, you add the.
Which ones do you want me to do?
Square.
You want me these go into a plus?
Yeah.
Then what about that minus that's in front of them?
Just leave it as is.
What minus?
This one right here.
That turns into division, right?
That's the division problem.
Yes, but if right now I'm saying minus this big chunk of stuff, right?
Yeah.
If this big chunk of stuff turns into two things, I have to subtract both, don't I?
No.
Yes.
Wait, yes.
Right? If I say take away A plus B, right? I have to take away two things. I have to subtract. I have to distribute that
So
subtraction.
you have to do that part first.
Well, it's up to you. I would do this. Look, let me try and help you see this. Minus, let me put a bracket.
Yeah.
Okay?
There you go.
There. Now, what are you subtracting?
Log.
Two logs, right?
5x squared, and then.
Plus. Does that help you see it a little bit?
Yeah,
That minus will have to go through to both?
I like that better.
Also, do you notice my cube root of 5 to the e turned into 5 to the e to the
Yeah,
1/3?
So you can put that out there in front.
Yeah, I'm going to drop that 1/3 out. So I'm going to go 1/3 log base 5 times e. And then over here minus 2 log base 5x. Can't do anything on this one, right? Minus though, log base 5x squared plus 4. This marker's done. Heads up. I don't think I'll hit you, but oh. Anything else I can do?
Take the, wait, no, you can't do the square root on the other one.
Yeah, I can't pull that 2 out because it's attached with the 4. 5e. What can I do with that 5e? This is 1/3, and then look, this is log base 5 of 5 plus log base 5 of e, isn't it? That was multiplication there. Now look, if you get it to this point, you're getting like, 8 or 9 out of 10 points here, okay? But if you forget this piece, that does simplify a little bit. What's log base 5 of 5?
1.
Yes, 1, good. Good. 5 to what power is 5? 1. So that's 1.
So if we write 1/3 log 5 of 5, we're going to get points off.
No. I'm saying it's not going to be a major thing, but it will be some minor little thing. 1. Now, log base 5 of e, you cannot simplify. You could, if you want, do this, but you could also leave it as log base 5 of e.
All you're doing essentially is just change it.
Change the base formula on that.
Do you want us to do that?
You could leave it like this, or you could turn it into this. I wouldn't.
Either way is any more correct.
That's right. I would accept both of those with no penalty at all. All right. But I do want everyone to see this, because normally on tests I do put one piece in here that turns into a number. Like I would normally not put that e in there, so that I would make sure everyone turned that into what?
A number.
This would be
So that would just be a third.
1/3.
It'd just
Yep.
be a third minus
Yep.
2 log 5.
Like
Yeah.
ln of e to the x.
Yeah, exactly. All right. Can I erase? Yes? All right. So what about the next one?
So you just wanted to condense it now.
It's the opposite way? So I would first start out by doing what?
The first one? The first two.
You want to push that 4 up?
Well, you're supposed to go from left to right.
2 to the 4th plus natural log x minus, what do you want to do here?
Can you bring the 2 to the
I would
4?
do everything in the brackets.
2 to the,
Oh no, the 2 distributes out to the whole thing?
you could distribute the 2 through. Yes, you can. There's nothing wrong with that. You distribute actually a -2 to each one of them in front. Or you could put those 2 together right now, right? Don't these 2 go together?
Yeah.
And they turn into a single log with multiplication, right? 4 times x plus 1, so 4x plus 4. Is that okay?
Yeah.
Now,
You can bring that 2 up.
you can bring the 2 up.
The -2 up, I'm sorry.
I'm going to leave it as a negative out there, though. And then I can put these 2 together, because that's addition. I can turn it into multiplication. So 2 to the 4th is 16. So 16 times x. And then minus over here, well, natural log of 4x plus 4, and then squared. And then now that can go into a single log with division.
Log of 16x over 4x, whatever that number is.
4x plus 4, quantity squared. There we go. That's condensed. Questions? At some point, okay, solving. Solving this log equation. How are we doing on time? We got about 10 minutes. You want me to keep going?
Yeah.
Okay, solve this.
So that's 1 to the 3rd power, or -6 power equals 164?
Yeah. Yep, that arrow.
A to the -3 equals 1 over 64.
Yeah.
I think this is one you just have to think through. Maybe not. Isn't this 1 over a cubed equals 1 over 64?
Yeah. So what to the 3 is 16?
Yeah, what number cubed is 64?
It's a 4.
Is it?
60, yeah.
4 times 4 is 16, times 4 is 64. It's not 2, right? 2 cubed is 8. 3 cubed is 27. 5 cubed is 125. So yeah, but just by a process of elimination. Now, if you wanted to, you could do like a cross multiply and do 64 is a cubed. And then at this point, you have to take cube root on both sides. But then again, you need a calculator or need to think through it. At the end, a is 4.
That took me a second to like figure out what you did with 1 over a to the third, and I just felt really stupid once.
With the negative power,
Yeah.
it drops down.
Yeah,
Yeah.
first thing I don't know why, but that always gets me. I'm like, I don't know what to do with this, but I'm like, okay. But that,
That's why we're here, because all these little things that you see in other classes, you don't want to be in those other classes where you're finally going, oh yeah. It needs to be more like, oh yeah, we did that. You know, like I've got that down.
yeah, I don't want to take your count one class.
Like,
and be
what are
like,
you
"Oh,
doing?
that
Yeah.
rate."
What? I don't know. Why is it? Okay.
I don't know
What about this one? Ooh, this one looks nasty. This is the type of problem that you look at and you're like, oh my gosh, this looks terrible.
No, it's actually not, because you do, the 27 is the base.
U sub?
I use the base.
What would your U be if you want to do U sub?
9x. Well, 9 raised to the x.
No,
Probably 3
no, it'd be 3 to something.
This looks a lot like that problem where you do U sub, but you don't need it. No.
Because the base should be 3.
The base is 3.
Okay, hold on.
Okay, explain how you would do it, I guess.
Okay, so this is this, right? This
Let's
is
say it's 27.
this is.
And then you just add those things.
Do you agree with that much?
Yes.
Yes.
And then you make it all a similar base.
We're going to make it all similar base. Let me put these two together first. If you have the same base, multiply, you add the exponents.
So
This is
it'd be
27
is x squared.
x squared plus 7x, right? Like that.
And then get the same base.
Now the same base. And the same base here would be 3.
3 on each
3.
side.
Yeah, because you can't rewrite 27 as 9 to a power.
Okay.
You understand what I'm saying?
Yeah.
You can, of course, write 27 as 3 times 9, but you need everything to the same power. So this is 3 cubed, that's 27, to the x squared plus 7x. And this over here is 3 squared to the x minus 3. That's,
You multiply that through.
yeah, now you go power to power, you multiply.
So 3x squared and then plus
3 to, hold on, 3x squared plus 21x. So I'm just multiplying this 3 times both of those. And then here, 2 times that distribute. So 3 to the 2x minus 6.
and then set the exponents together.
Yeah, since you have the same base matching, you just set the tops. And you've got a quadratic at this point. And that should work out. Hopefully this will factor.
Hopefully, be nice. 19x plus 6.
Yes.
Yeah.
3x
times
x 6 plus 1 equals 0. That should work.
Yeah. So x is -6 and 1/3.
Do,
Negative 1/3.
yeah, do you have to check your answers in something like this?
Probably.
What type of equation was this? Exponential or logarithmic? Exponential. You don't necessarily need to check your answers with exponential. You have to be careful with logarithmic ones. Because remember, the domain of an exponential is all real numbers, so there's not going to have a problem of not being able to plug something in. Okay. So that one looked kind of like the U sub problem, but it wasn't quite. What you would be looking for with the U sub is for this to be 2x, not x squared. Look back from last class and you'll see what I'm talking about. See, like this one, well, this one probably, whoa, what? Okay. So biggest mistake people make, they make that 50 raised to the 2x. You can't do that, right?
Could you make it 3?
You could divide the 5 out.
You could divide the 5 out. Good. And then what would you want to do there?
And then you're gonna set the bases equal to each other.
That's working. I don't think you'll be able to do that. If you want to pull the x out, right, why don't you just come in with natural log now?
Yeah.
Yeah. So natural log of 10 to the 2x equals natural log of 3/5. And then the 2x pops out over here, natural log of 3/5.
And that's a number.
Yeah, this is a number, and then 2.
And you divide that by.
You divide through. So this is a calculator problem. You got to get your calculator and do all this, but you're going to wind up figuring out what that is and dividing it by this and dividing it by 2. So that's really the computation you have to do there.
So
Understand?
Would that be an acceptable answer?
You could leave it like that. I like that.
Okay.
That's what we call the exact answer.
So we're gonna divide it twice, first by the element 10, and then we'll bring 2 over later on.
Oh yeah, so
Or you can do it
technically
all at
it's
one
actually gonna
time.
be more accurate than actually giving
This
it.
is more accurate than a decimal, which is a lot of times in math, as we move forward, we like exact answers as opposed to approximate.
Well, I've seen like more complicated math. I was looking at it, especially when you get in chemistry. If you have all those decimals and stuff, you know, it's a lot.
You can get a lot of error, E-R-R-O-R, if you start getting approximate answers. Like we did with the exponential function there, the decay. You start rounding everything, you start running into problems. All right, let's see how much further this goes.
It's all the way to 25.
All right. This one, okay, this one is the one that would be a U sub,
You said.
right here. Because you would rewrite 25 as 5 squared to the x plus 2 times 5 to the x equals 8. Change this as 5 to the 2x, or you know what, better yet, 5 to the x squared. There you go. Okay, yes?
Yeah.
Plus 2 times 5 to the x equals 8. Now u is 5 to the x, and u squared plus
Plus 2x.
minus 8 equals 0. So I brought the 8 over now.
And then you just solve for u.
Solve for u.
So
So u plus 4, u minus 2,
u is
negative 4, u is 2. Means 5 to the x is negative 4, 5 to the x is 2. And this one you can't, there's no solution. And this one, natural log both sides and work through. Yeah, negative, can't have it.
And then the other one's just a weird number.
Another log equation. Okay, so on this one, check out what you would do. You pop the 2 up, okay? Then you put these 2 together,
Multiplication.
and then you have log of something on the left, log of something on the right. Same log, same base, you match the insides. So if that goes up there, it's 4 minus x squared, right, with the log in front of it, equals log in front of this one. When I put those together, I get 4 times 13 minus 2x. So I have the same log on both sides, right? So you just match the insides. So my next step would just be to write that down. And then expand this out, multiply it all out, expand this out, bring everything to one side because it's a quadratic.